Today I want to teach us two things. One, we are going to look at how to name these two organic compounds. Then, secondly, we are going to look at Markovnikov rules. Okay, the first is what? To look at how to name these two compounds. We have CH3, CH bracket Cl bracket CH3. Now, we are going to turn this molecular formula into a structural formula so that it will be less complicated for us to name. So we have this C bonded to 3 hydrogen atoms, then bonded to this carbon that contains only 1 hydrogen atom, then bonded to a chlorine atom, which is in bracket or parenthesis, then bonded to this particular carbon that contains 3 hydrogen atom. This is exactly how to write this molecular formula in structural pattern. Now let us name it. We have 3 carbons here, which is prop. Then the functional group here is single bond. You can notice that for all of them, they are all what? Single bonds. So we are going to end it as ane. Ane. This ane is coming from a homologous family we call alkane. Then the next thing is to look for the position of this substituent group, which is a halogen, chlorine. So if we choose to number it this direction, we can still see that the chlorine is bonded to carbon 2. If we choose to name it from here, to number it from this other side, it is still under what? Carbon 2. So we will choose only one pattern of numbering. So at the end of the day, this is going to form what? 2-chloropropane. This is how to name this compound. This compound was formed by a reaction between a propene and a hydrochloric acid, right? Or you can call it hydrogen chloride. Now, there is a pattern of naming the whatever that will be formed, and this is going to be guided by what we call the Markovnikov rule. So how do we realize this? Let us bring out the propane. Now this is prop for 3 carbons. I am bringing out the functional group, which is a double bond, right? So we'll complete this other one by what? H. So we have this, right? So then we have 1, 2, 3. So we only have 1 more hydrogen to attach to this carbon. Then for this carbon, we will put 3 hydrogen. You can see that all of them have total number of 4 bonds. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. And then this carbon has what? 1, 2, 3, 4. This reaction is between this compound you are seeing here, which is prop1N, and a hydrogen chloride. So the reaction is going to what? Add hydrogen to the particular carbon that contains more hydrogen, and then chlorine to the particular carbon that has lesser hydrogen. This rule is called Markovnikov rule. In a situation whereby we add hydrogen to the carbon that has more hydrogen, and then the halogen to the carbon that has less hydrogen. All right. So because the alkene is unsaturated, we are going to break the bond. The pi bond will break to leave us with single bonds, right? So we will have this, and then this, and then so if we still have double bond here, this hydrogen will come and break one of these pi bond, and then the hydrogen will be given to the particular carbon that has more hydrogen. So between this carbon and this carbon, this has 2 hydrogen, whereas this has only 1 hydrogen. So the hydrogen will be attached to the carbon that has more hydrogen, and then this chlorine will now come and attach to the carbon that has the lesser hydrogen. So this is the product that is formed. Let's see how to name it. It is going to be prop, right? Prop. And then we are going to repeat what we said for this, because this is exactly what we have written here. I just showed us the rule that brought about the formation of this particular compound. So we said it's the prop, then we consider the functional group is single bond. That means it will end as ane, right? Then the carbon that carries the substituent group, which is chlorine, is carbon 2. So that will be what? 2-chloropropane. So this is it. The next thing we are going to look at is what happens to this particular compound. This is slightly different from what we have here, because here we do not have any hydrogen attached to this carbon, and then we have hydrogen attached to this particular carbon. So let us see exactly what makes the difference between this and this, right? So we have, let's draw the structure, and then we'll consider how the particular compound was formed. So we have C attached to what? 3 hydrogen atoms. Then this carbon is attached to this carbon that contains 2 chlorine atoms, and then attached to the carbon that has 3 hydrogen atoms. So how do we name this? To name this compound, we will consider the longest chain, which is what? 3. That means it is prop. And then the functional group here is what? We have what? This is ane, single bond. So that is ane. So it's going to end as propane. Then we are going to look at the substituent group is attached to the carbon, to the second carbon. If we choose to name it number it from here, 1, 2, 3. So it is under carbon 2. So we have what? 2, because the 2 chlorine are the same and attached to the same carbon. So we have 2, what? Dichloro. Why are we saying dichloro? Because the chlorine are 2 in number. So we have 2,2-dichloro what? Propane. Now let us see how this compound was formed following the Markovnikov rule. This compound came from a propyne. Propyne will contain 3 bonds, 2 pi bonds and 1 sigma bond. So we are going to have this, right? So 4 bonds to this carbon. Then this particular carbon has 4 bonds, 1, 2, 3, 4. So it is complete. This one has 1, 2, 3. So it will now contain additional 1 bond to hydrogen atom. So this is prop 1-ine. Prop 1-ine. Okay, so this will react with hydrogen chloride, right? or any of the hydrogen halides. It could be hydrogen bromide, it could be hydrogen iodide, right? So when this reaction happens, it happens in two stages. The first stage is going to break one pi bond to form an alkane. Then the last stage will break the remaining pi bond to form an alkane. And then when an alkane is formed, you know that it has become stable and saturated, right? So for now, this is an unsaturated hydrocarbon since it contains multiple bond. When it has 2 bonds, it is unsaturated. When it has 3 bonds, it is also unsaturated. So let us break this bond. The first stage will be the formation of this C we are now going to, okay, let's just keep the 3 bonds. I'll show you how it breaks the bond. So when the first hydrogen breaks the first pi bond, it will give the hydrogen to the particular carbon that has more hydrogen. Between this carbon and this carbon, this is the one that has more hydrogen because this has hydrogen but this one does not have. So to obey the Markovnikov rule, you will give the carbon that has more hydrogen the hydrogen. So we give this to this carbon, right? Chlorine atom will now be attached to this other carbon. So this is the first product that is formed, which is 2-chloro-prop-1N. We are giving this double bond to this carbon 1, not this carbon 2. So it is 2-chloro-prop-1N. Now, to finish up the reaction, this particular compound will now react with HCl to give us the final stage. The final product will be what? When this hydrogen breaks this remaining pi bond, it will give the hydrogen to the particular carbon that has more hydrogen, which is this particular carbon, right? Then the chlorine atom will be given to the one that has less hydrogen, which is this. This is what forms, obeying the Markovnikov rule. So at the end of the day, the product that is formed is named as what? This is 1, 2, 3, right? So it is carbon 2 that carries both chlorine atoms. So the name will be what? 2,2-dichloropropane. So this is how we react an unsaturated hydrocarbon with a hydrogen halide, and then following Markovnikov rule we get a product. So thank you for watching this wonderful video. Do well to like and subscribe to our YouTube channel and share to your friends and contacts.